let's talk about determining the number of stereoisomers that you can draw when given an alkene with one double bond, two double bonds, or even three double bonds, right? Now, what you the formula you use is 2 raised to the power of n, right? Where 2 raised to the power of n, where n represents the number of carbon-carbon double bonds where you can observe cis-trans isomerism, right? And I, you probably have forgotten, but I'll show you what you need in order to observe cis-trans isomerism. So for example, let us look at 2-butene, right? And I'm going to draw cis-2-butene, carbon one, two, three, four, right? This is cis-2 butene. Now, if you're asked how many stereoisomers can you draw for cis-2 butene or just 2-butene, this is how you answer that. Find the carbons of the double bond. Remember, in order for a double bond to show cis-trans isomerism, each carbon of the double bond must have one hydrogen. So this group has to be something different. This carbon needs to have one hydrogen. This carbon needs to have one hydrogen only. One hydrogen only on this carbon, one hydrogen only on this carbon. So you only have one double bond, right? That shows that you can have cis-trans isomerism. This double bond shows that you can have cis-trans isomerism. And I already said it's because you have one hydrogen on this carbon, one hydrogen on this carbon. So N in this case is 1. So this is 2 raised to the power of 1, which is 2. Which means that for 2-butene, and I have one of the isomers here, you can draw 2 stereoisomers. The second stereoisomer is trans 2-butene. You can draw that. Trans 2-butene is simple. You literally just put the hydrogens on opposite side of the carbon-carbon double bond, right? What if you're given a question though that has 2 double bonds? Let's say you're given this, right? It's a diene, carbon 1, carbon 2, 3, 4, 5, 6, right? You need to go to, let me take these numbers out. You need to go to the carbon-carbon double bond, right? And firstly, put in your hydrogens, right? And I know there's one hydrogen on this because I see one, two, three bonds. So only one hydrogen was missing, right? I see one, two, three bonds. Only this one hydrogen was missing. Also put your hydrogen in here. See, I know one hydrogen is missing because the carbon need 4 bonds. One, two, three. If you don't remember, go back to line angle structure. All right. Now, we need to determine N. N is the number of double bonds where you can observe cis-trans isomerism. Remember, for you to observe cis-trans, what you're looking for is one hydrogen on each one of these carbons. So this has one hydrogen. So we're on our way. This carbon also has one hydrogen. Each one of these must have one hydrogen only, no more. So yes, this double bond right here can show cis-trans isomerism. Move to the next double bond, which is here, right? This carbon has one hydrogen. The rest of this is a group. It's not a hydrogen. This carbon also has one hydrogen, which means at this double bond, I can also observe cis-trans. That's all you're looking for. Find the double bond. Look if each carbon of the double bond has only one hydrogen. These are the carbons of the double bond. There's one hydrogen here. There's one here. So I have 2 double bonds, this one, where I can observe cis-trans isomerism. So 2 raised to the power of 2 is equal to 4, which means that, let's name this 1, 2, 3, 4, 5, 6. Let me use a different number so you can see blue. 1, 2, 3, 4, 5, 6. So it means that for, I have a double bond between 2, 3. So you write 2, comma, where's my next double bond? It's between 4, 5. Take the lower number 4. 6 carbons in my longest chain. Hex, it's 2 double bonds, a diene. So for 2, 4 hexadiene, you can draw 4 stereoisomers. Okay, let's look at this one. So let's see how many stereoisomers we can draw for this. The usual, find your carbon-carbon double bond, put in your hydrogens. This has one hydrogen here. You have a carbon here, right? This carbon, as you could see, you have 2 lines towards the dot, right? So it means that this carbon, so let me draw a carbon. This carbon has 2 bonds, which means what's missing is 2 hydrogen, right? Do the same thing here. 1 hydrogen here, 2 hydrogens here, so the carbon can have 4 bonds. If you have forgotten line angle or you don't know what I'm talking about, go watch my video on line angle formulas. Now, if the question asks how many stereoisomers can you draw for this, right? The usual, go to your double bond. Carbon-carbon double bond. This carbon has 1 hydrogen. This carbon of the double bond has 2. Cannot have cis-trans isomer. 0. 0 cis-trans isomer over there. We have the same thing here. Here's the carbon of the carbon-carbon double bond. This only has 1 hydrogen. This, however, has 2. Cannot have cis-trans isomerism. So the total number of stereoisomer here is 2 raised to 0 because none of these double bonds will ever show cis-trans isomerism. So it's 2 raised to the power of 0, which is equal to 1. So you can only draw 1 stereoisomer of this, and it's the compound that you see on screen. That's how you handle a question like that.